Hi ladies, this is lesson 1.9 and this is about transformations. So you can see a few key vocab terms and we'll go over those in the lesson today. So on your first slide, if you're following along on your guided note sheets, lists 3 types of rigid transformations. Rigid transformations are transformations that preserve the size and the shape of the original image. So a rigid transformation is a transformation that carries the eye symmetry characteristic. Which just means it's congruent to the original figure. So an image that is transformed using a rigid transformation, and we'll go through those types of transformations, but an image that's transformed under a rigid transformation has the same size and shape as the original image and therefore is isometric. So it has eye symmetry. So in the first one, we've got, here's our original image. And then here is our isometry or isometric image. And this type of rigid transformation is called a translation. In the second image, the one that has the star, here's our original, and we're transforming it to get our isometric image, and we're using rotation. And the third one, we have our original image, and we are transforming that image to get an isometric image, and we're using reflection to do that. So a rigid transformation preserves the size and the shape of the original image, such as in a rotation, a translation, or a reflection. But a non-rigid transformation, the size or the shape changes and is not isometric to the original image. So the first type of transformation that we're going to look at is the simplest type, and it's called a translation. So you can think of a translation if you think of sliding an image across a piece of paper. And if you're sliding it, you're keeping the orientation of the image, but you're sliding a figure on a straight path. From one spot to another. All points of the image move the same distance along parallel paths. From the original orientation of the image. And therefore, each point on the image is equidistant from the point to the that corresponds to it in the original figure. This distance from the point on the original image to the point on the translated image is called the distance of the translation. Each translation will be given a particular direction and to describe how you should translate your image, and this is called the translation vector. So, for example, Let's look at the image that you have on the bottom of your page. And you have a star. Well, if I took that star and I slid it across a straight path without turning it or rotating it or reflecting it at all, just sliding it, and we'll make it yellow. Each point, oops, each point is the same. Oh, let's see. Let's change that star. Let me just try this again. Delete that. All right, here we go. Make the star a different color. All right, so each point on the star is the same distance away from its corresponding point in the original image. So this point and this point are the same distance away as these 2 points and as these 2 points and as these 2 points and as these 2 points. And then you could do the all other corresponding points and so forth. In addition to all of those segments that I just drew being the same distance, they are also parallel. So this line is parallel to this line. All of these lines are parallel. So those are properties of a translation. So another couple examples, the seashell. Here's your translation vector. It's telling you to translate the seashell in this direction, and you're not turning it or anything, you're just shifting it. We'll do an example in class with patty paper, or wax paper, or folding paper. And then you can see translations on a coordinate grid. So here's your translation vector. Tells you which direction this translation is going, and you can see that they're all just shifted. They're not turned or shrunk or stretched or anything, they're just shifted. Okay, so now you try. So it says translate the figure by the translation vector. So it tells you exactly which direction you should go and how far. So feel free to pause the video while you work. So we are going to want to move each point of this original figure 3 spaces to the right. So I'm going to start by the straight line ones because I think that's probably the easiest. So move all of those points 3 units to the right. And then I'll just use this one as kind of a guide. 1, 2, 3. And maybe this one too is kind of a guide. 1, 2, 3. Here we go. 1, 2, 3. And now I will just, maybe I'll do this one too. 1, 2, 3. 1, 2. And now I just connect all of my dots to make my translated figure. All right, the second type of transformation is a rotation. And with a rotation, all points in the original figure rotate, or turn an identical number of degrees. An identical number of degrees about a fixed point. And this, again, just means around a fixed point. A rotation is defined by its center point, the number of degrees turned, and whether it's turned clockwise or counterclockwise. If there is no direction given in the rotation, you can assume the rotation is clockwise. At the bottom of your sheet, you can see a couple examples, or one example, and again, we'll do some examples of this in class. But here is the center point, and the figure is rotated a specific number of degrees. So this will be, you will have to measure this distance right here, and to rotate it, you'll do the same distance from the center point, but at a different angle. Okay, so let's try with the figure that's in your notes. We want to rotate 180 degrees about the center point. So 180 degrees is a straight line. So in this case, it doesn't matter whether we go clockwise or counterclockwise, but again, if it doesn't specify, then you should do clockwise. So 180 degrees from this point, about the center point, is right here. And I'm going to use colors to correspond so that we know what points to connect. This point, again, 180 degrees is a straight line. And you can use your protractor if you want. But this point will get rotated here. Then this point, and again, we're going to go 180 degrees. Let's see. 1, 2, 3. So if I draw my line, here's this point. And then we'll move on to our green point. I'm going to use actually the actual dot line. So here, 180 degrees falls on this path. So that is here. I'm just going to delete these so we can see the next ones. Look at our light blue one here, and 180 degrees, again, is a straight line. That brings us here. Oops. Right, and then our last one is our dark purple one. And 180 degrees. That's 2 units. 1, 2. So all of our, use a smaller pen. All of our points are the same distance as they were before from the center point. Those are the same distance here. So P is the center point of all of our segments that I just drew in. And you don't have to draw those in, that's just so you can see. But now I actually want to connect all my points just like they are in the original image. So the blue one goes to the red one. And, sorry, the purple one goes to the red one. And the purple one also goes to the blue one. And the blue one goes to the green one. And the green one goes to the light blue one. And the light blue one goes to the purple one. And the purple one goes to the red one. So it's the same image, it's just rotated about point P. Then our third type of rigid transformation is called a reflection. And a reflection is a type of transformation that produces a figure's mirror image. So just like you look in the mirror, you see your reflection. That's what we're talking about, but with figures and stuff. So if you draw a figure on a piece of paper and you place a mirror perpendicular to your paper and look at the figure in the mirror, you'll see the reflection image of the figure. And the line where the mirror is placed is called the line of reflection. So this image here is our line of reflection. The G here, this is our line of reflection. So we have our original, and then we have our translated image. So now you try with a reflection. So how would you see it if you placed a mirror along line L, which is the line of reflection? So I'll start with this first one. This first one is 2 units from the line of reflection. This point here is 1 unit from the line of reflection, and it's perpendicular. This point is 3 units. From the line of reflection, 2 units from the line of reflection, 4 units from the line of reflection, 1 unit from the line of reflection, and 3 units from the line of reflection. And then we connect our points. And there is our reflected image. So on your own, take some time to think of these summarized questions. So what's the difference between a rigid and non-rigid transformation? How could symmetry be considered a transformation? And again, we use the isometric images. So think of that term as well. And why are reflections described by mirrors instead of flipping? What's the difference between mirroring and flipping? And then there's an extra example that you can use a coordinate grid. So if you have graph paper, do that extra example on graph paper. If not, do the best you can on dot paper or makeshift graph paper. You can always print graph paper out online too. And then reflect that image across the y-axis. Then translate the triangle 2 units to the right and 3 units down. And then rotate the triangle 90 degrees clockwise about the origin. And then just to get you thinking, and you can jot these letters down as well, which letters in the English alphabet have rotational symmetry. All right, and as always, jot down any questions you have and bring those to class on next week. Thank you.